paper. Smooth side, rough side. You want to fold it so the rough side is out. Okay, so you're going to fold a vertical line. Open the paper and write your name. You're going to write it on the rough side. It's easier if you write it on the rough side. Okay? So then you will have, I'm going to write it right on the line. It says write your name on one side of the line in uppercase letters. So that's what we're going to start with. Everyone go back to your different. It's really different. Okay, so write your name in capital letters. That's the next step. Open it back up and write your name in capital letters. Create a reflection of your name. So reflection means like if you're standing in a mirror, you see your reflection in the mirror, right? If I raise my left hand in the mirror, my left hand is also raised in the mirror. So reflection, I want you to create a reflection of your name. Explain to a classmate how you created it. So this is like your mirror right here. I want to see a reflection over that line. So it says the same thing. So if you were to fold it, it would match up. I'm giving you a very big hint right there. If you were to fold it, it would match up. How could you create a reflection over that line? Give it a try. All right, do you have an idea of how they create a reflection? I thought that people do it. How could I create a reflection? What did you do? What did you do? What did you do? You see paper that was folded, and she wrote it on the other. Can you see that? Can you see that? So let's say I traced it. Do I have a reflection of my name? Is that a reflection? Okay. That is a reflection. A reflection says that there is a line down the middle and they match up perfectly. And look at that. If I were to fold that, does that match up? Yes. That's a reflection. It doesn't matter what I draw. I could draw a flower over here. Flip it over. I can trace the same flower and you have a reflection. That's what we're going to be working with today. This line that I folded here is called a line of symmetry. A line of symmetry just means whatever's on one side is on the other, and if you fold it, it matches up. So like shapes have a line of symmetry. If I were to have a square, a line of symmetry would be right down the middle, right, where I just fold it and it match up. Okay? A heart, does a heart have a line of symmetry? If I were to draw one, if I drew half a heart over here, could I have a line of symmetry and draw the other half of the heart over here? So that line of symmetry just cuts it in half. And it matches up. Those are all reflections. Does that make sense so far? Okay. So, now we're, all right. Graph a triangle at the top of the grid below. This is your preimage. So I'm just going to put a triangle up here. Not asking for a big one. I'm going to make a right triangle just for very easier. Go ahead and draw that triangle. This is our preimage. I'm just going to write in it. This is our preimage. It says draw a horizontal line on the grid below your preimage. This is your line of reflection. I'm just going to draw it right here. I'm not going to go too far below it. Okay, that's our line. Line of reflection. Create a reflection of your triangle below the line without folding the grid paper. So, this is just like your patty paper. There's your line. And I need this triangle down here as if I were to fold on that line and it would match up. But you can't use your patty paper. So how can I get this image reflected down here, but it has to match up? Try it. See what you can do. How they could do that? How could I reflect this image down here? Let's say I give this A, B, and C. How far away is A from my line of reflection? How many grid spaces is my line of A away? 2. So would it be okay, I go down here 2? Would that ensure if I folded this line, it would match up to that A? Okay. How far away is B from my line of reflection? So I'm going to go 1, 2, 3, 4, 5, 6. Would that also ensure that B, if I fold along that line, that it would match up with B? How far away is C? So I'm going to go down 2. Would my new image of my triangle, if folded along this line, match up with that triangle? Yes. That means I've got a successful reflection. Okay? So now, if I were to take this grid paper, like it's saying, and go right upon that line, I can see that it's going to match up. All right, here's the big question, and this is the question you are going to get asked on ITAC. This is what they do. Are the free image and image congruent? What's the word congruent mean? The same. So are the free image and the image congruent? Yes or no? What do you think? Congruent means the same. So are they the same perimeter and are they the same area? Are they the same shape? Yes. So are they congruent? Yes. When working with polygons, do reflections always create a congruent figure? What do you think? We're reflecting over a line. Is that always going to create a congruent figure? When you reflect, do you change the size? Do you change the shape? Do you change anything but the position? So is it always going to be congruent? Yes. The only thing in the position. Okay. Questions about to explore at all? I would say reflection and translation are going to be the easiest for you to do. The only one that kind of creates a little bit of a thing is making. I do not want to find this patty paper all over my floor either. So if you don't keep it and put it in your place, way am I in it? It is flying by. You should be able to get this done with unit 8 and 9 next week. Okay, this is unit 7 is really fast. We're doing some ISAC reviews this week only because, as I said, you guys are coming up on ISAC. And I think ISAC is a vocabulary quiz, in my opinion, not necessarily a whole math quiz. If you don't know what the word congruent is, can you really answer the question? No. Okay, on an XY coordinate plane, if you don't know that means graph, you can't answer the question. So we're going to go through just some vocabulary words like that because you really know everything they're talking about. They're just using a whole bunch of weird names. Okay. I can reflect an image on a coordinate plane. You can, you've already done it. Okay, we did it on a grid, now we're going to do it on a coordinate plane. Okay. If I say the word shape, what comes to your mind? Triangle, what else? Circle, square, rectangle, octagon, those are all shapes, right? Okay. If I say the word transformation, a transformation is a reflection, a dilation, a rotation, a translation, just like square and shape. Okay? So we throw everything under this umbrella that's called a transformation. There's different types of transformations, just like there's different types of shapes. Okay? So the word transformation, the movement of a figure on a graph so that it changes size or, this is big, or position. A reflection, does a reflection change size? Did that triangle change size? Did it change position? Okay? So it's either going to change size or position. Okay. Pre-image is the original figure prior to the transformation. You know that. The image is the new, whenever we do the transformation, that's our new image. All right, and today specifically we're talking about reflection. A transformation in which a mirror image is produced by flipping a figure over a line. Okay? We did that with our patty paper. We drew our line and we reflected it over that line. Okay. All right, so now what the only difference is we're going to start talking about it on a coordinate plane. Okay? So, the vertices of a pre-image are often labeled with letters. After the transformation occurs, the new image has vertices that are labeled with the same letters, but it has an apostrophe added to it. That apostrophe, we call it prime. So, here's my pre-image. It says A, B, C. The new image is called a prime. B prime, C prime. That's what, by adding that little apostrophe, that's all it's saying. Is that, so I know that this was my original image, and this is my new image. That's why they did that. Does that make sense? Okay. All right. So, we're going to start off with a point. Okay? It says, the point D, negative 3, 4, is reflected over the x-axis. What are the coordinates of its image? So we're going to just graph the point D. We've got it here over negative 3, up 4. We need to label it though. That's D. What did you say? Okay. So we need to label that. We did that. Now we're going to reflect it as it says over the x-axis. Okay. This is the y. You're really going to have to remember your axis. That's what I'm telling you. This is your y-axis. I remember because it finishes out the tail of my y. I say it every time. That naturally leads this guy to be your x-axis. So I want to reflect it. So what they're saying is the line x is my line. You know this fold? Like you fold it on your patty paper? That's your x-axis. And we're folding it along that line, so I want it reflected over that line. So it's staying on the point -3, but how far away is it from the x-axis? How many squares? 1, 2, 3, 4. So I have to go down. 1, 2, 3, 4. What am I going to label that point? D what? Prime. So I'm going to put that little apostrophe. This tells me this is my new image and this is my pre-image. Okay? Question so far. Okay. Go to the top of the next page here. I want you to plot, we'll plot the point together. Okay? Says the point P, over 9, down 2. Over 9, down 2. P. Is reflected over the y-axis. I want you to give me my P prime. Okay, how should I do this? First of all, let's identify, am I going to go, is it going to be coming up here? Is it going to be coming up here? Because that would mean I reflected over the x-axis. I need to reflect over, like it said right here, y-axis. So I need to go over, so that means this is your fold line, right here. So I need it to match up over here. So I'm just going to count. I'm going to stay on this line. I went over 9, so I got to go over 9 and put P prime. How important is that prime to me? Very important. If you don't put that prime, I don't know which image was your pre-image and which one's your image. Okay. So I put that in here too. Reflecting over the y-axis looks like this. Reflecting over the x-axis looks like this. Questions? What questions do you have about? Okay. Now we're going to get into shape. So I've already graphed the image for us. We don't have to do that. You're welcome. Thanks for shooting. Oh, I did well. You're the best. I know. Oh, hi. Okay, so I've already graphed the pre-image. It says, graph the image RST under the transformation rule X. So this is what it is. This is our current, and it wants me to do this. Now here, let me explain what that's saying. Did your X switch to the opposite sign? This is what it is now. Did the X switch to the opposite sign? Or did it stay X? Stayed X, right? Did my Y switch to the opposite sign? It was a regular Y, now it's a negative Y. And it doesn't mean it's switching to a negative, it's still switching to the opposite. It's positive, now it's negative. If it would have been negative, I would have switched it to So all we're going to do is we're going to write our new rule. R. I am not changing any of the x's. See, so the x told me to stay the same. X, x. I'm just going to write it on my x's. What did it tell me to do with the y? Make it to its opposite. Because look here, this is already negative, right? So I need to switch it to its opposite. What's opposite of negative 3? Okay. What's opposite of negative 1? Positive 1. What's opposite of negative 1? Positive 1. That's all that rule is saying. Now we're going to graph these. 4, 3. So I go over 4, up 3. R prime. Over 4, up 1. S prime. Over 1, up 1. And I know that you guys are familiar with graphing because you were doing it last week. It's fine. So what's the axis that it reflects over? X or Y? X. So this rule, when we change the Y to its opposite, reflects over the x-axis. Okay? Does this make sense, what we just did here? What questions do we have? Okay, we're going to try this again now. I'm going to write the coordinates with you, the current ones, and then you're going to try to apply the rules. Notice here, which one's changing to its opposite? X, and what's happening with Y? Stays the same. So we already have these coordinates. I'm going to write them again for you. They're right up top. Here's our free image coordinates. Here's our free image. You apply this rule. What one am I changing? The X or the Y? Which one am I changing? X. I'm changing it to its opposite. So 4 is positive. What is it now? Negative. And my Y's are all staying the same. So this will be negative 4, negative 1, negative 1, negative 1. So I'm going to reflect that over to negative 4, down to negative 3. R prime. Negative 4, negative 1. S prime. Negative 1, negative 1. P prime. So what axis should I reflect that over? X or Y? Y. This is reflected over the Y axis. Almost done, guys. Really close. Reflections over the X and Y axis. So these are the rules that we just went over. If you change the Y to its opposite, you're reflecting over the X axis. If you change your X to its opposite, you're reflecting over your Y axis. Ooh, sit up here. Okay. A square has the coordinates M, negative 4, 2, N, negative 1, 2, P, negative 1, negative 1, and Q, negative 4, negative 1. The square is reflected over the y-axis. What are the coordinates of the image? So what are the coordinates of my new image? If it's reflected over the y-axis, which coordinate are we changing to its opposite? X. So, M prime, is it going to be negative 4 anymore? What's it going to be? Positive 4. Am I doing anything to the 2? No. We'll just write it down. And we're going to the next one. N prime. What am I doing to the negative 1? Changing it to what? Positive 1. Am I doing anything to the 2? Nope. P prime. What's happening to the negative 1? Going to a positive. Am I doing anything to this other negative 1? No. Q, what's happening to the negative 4? Positive 4. And am I doing anything to the negative 1? No. So these are my new coordinates. You will see this on ISAC where they say, you don't have to graph it. They're just going to ask you what the new coordinate is. That's what this is. That's all this is doing. They gave you a rule, and it said, what's the new coordinate? Does the shape change? Does the physical shape change? Does the size change? Therefore, does the area change? Does the perimeter change? It's just in a new position. Okay, last thing, we're going to put it all together. A triangle has a coordinate of A, 2, 0, N, 7, negative 1, and P, 5, 4. The triangle is reflected over the x-axis. So which one's changing, the x or the y? The y. So that's this rule. Here's my original. Okay, this is this rule. What's the new coordinate? And graph both images, the pre-image and the image. Graph them both. over 2 up 0, A, over 7 down 1, N, over 4, 5 up 4. You guys agree with my ant triangle? Yes? So my new A prime, is there such thing as a negative 0? So can I change 0 to its opposite? Say 0. Oh, what did I write B? Yell at me. Do you agree with my new coordinates? Did I do those correctly? Okay. So A prime is going to be in the exact spot. Over 7 up 1 is N. And then B prime. Is it okay that they overlap like that? Which axis did I reflect over, the X or the Y? What axis is that? X. Right, you have to put by